Injection mold. And yeah, it looks like a crazy, complicated 3D puzzle box because, well, it is. But it's really just made of several key systems that all have to work together in perfect harmony. So let's break them down one by one. Right at the very heart of the mold, you have the core and the cavity. These are basically the two halves that press together to form a negative space. And that space is the exact shape of the final part you want to make. They control everything from the most precise dimensions right down to the final surface texture. So, how does the hot molten plastic actually get into that cavity? That's the job of the feed system. The best way to think of it is like the mold's circulatory system. It's this whole network of channels that guides the plastic all the way to a tiny little opening called the gate, which leads directly into the part. Now, once the plastic is in there, it's incredibly hot, so it needs to cool down and solidify. That's where the cooling system comes in. And if you get this part wrong, you're going to get warped, twisted, unusable parts. It's this intricate network of channels, almost like veins running through the steel, that pull heat out as quickly and as evenly as possible. And finally, once the part is solid, how do you get it out of there without breaking or scratching it? Well, you call in the ejection system. I love this analogy. I like to think of them as the bouncers of the mold. It's a perfectly coordinated system of pins that just push the finished part out cleanly without leaving a single mark. So we've met all the key players, right? The core, the cavity, the feed system. Now let's see them all in action in what I call the five-step dance of injection molding. It's this perfectly timed sequence that can create a brand new part every few seconds. The entire cycle, from start to finish, can be broken down into these five main steps, and each one plays a critical role. We have clamping, injection, packing and holding, cooling, and finally, ejection. So, let's walk through the journey of one single part being born. Okay, it all kicks off with clamping. The two massive halves of the mold are slammed shut with literally hundreds of tons of force. You have to fight the injection pressure. And then, immediately, the injection phase begins. A shot of molten plastic is forced under incredible pressure through that feed system and fills up the cavity in a flash. Next up, we have packing and holding. Now, the pressure is kept on for a little bit to pack in just a little more material. This is super important because it compensates for shrinkage as the plastic starts to cool. And then comes the longest and arguably most important part of the cycle, cooling. The part just sits there in the mold as that cooling system works its magic. And just how long is that cooling step? You might be shocked to learn that a staggering 70 to 80% of the entire cycle time is just dedicated to cooling. Think about that. A 10% reduction in cooling time could mean a 7 or 8% increase in your total output. Every